Alright, this is your review of your practice quiz. I'm going to go over this kind of quickly, so this is just to give you the answers. You should have already tried it and gotten some things done here, okay? If I want to know in which quadrant 11 pi over 8 is, I'm going to do number 2 first because I'm going to actually sketch that in standard position. Standard position means that it's going to start from 0 and it's going to go around until it opens up in the counterclockwise position until it gets to 11 pi over 8. Well, I know this is pi using a common denominator, so that's 8 pi over 8 here. So I know I have to go at least that far. I'm going to have to go some more. Well, I want to know if I go past this 3 pi over 2, right? And 3 pi over 2 is the same thing as if we multiply that by a common denominator, which would be 4 over 4, right? So that will give me 12 pi over 8. So if I want 11 pi over 8, that should be about right there, right? And there's my angle in standard position. Starts at the 0, ends at 11 pi over 8. So this is my 11 pi over 8. So there's number 2. It's been sketched. And which quadrant is it in? Well, this is the quadrant 1, 2, 3, and 4. So it's in quadrant 3. Give a positive coterminal angle. Well, that means I'm going to go around one more time. If I go around one more time, I'm going to take my 11 pi over 8. I'm going to add one full circle, which is 2 pi. And I can do that by getting a common denominator. I need an 8. Excuse me. And that's going to give me 11 pi over 8 plus 16 pi over 8, which is equal to 27. 27 pi over 8. All right. Now we're going to get a negative one. So a negative one, we're going to go backwards. And if you notice here, if we go backwards, we're going to end up with one full circle. So we're going to have to subtract. So we're going to go 11 pi over 8. I'm going to subtract 2 pi. Remember that 2 pi is really 16 pi over 8. And that'll give me a negative 7 pi over 8. Alright, great. Let's continue. Number 5. Number 5, convert the angle to degrees. So we have 11 pi over 8. And we know my conversion is 180 is equal to pi. So we're going to put 180 degrees over pi. Oh, sorry. Let's see, let me undo that. 180 degrees over pi. And then we can see that my pi's will cancel. You can do some reducing here. I believe that reduces by 4. That goes in there 45 times. And if you forgot that trick about multiplying by 11, you take let's see, did I do that right? 4 goes into 180 45 times, yeah. So that will be 4. Take anything times 11 would be, split them apart, 2-digit numbers. add the two numbers, 4 and a 5 goes in the middle. Okay, and then you just divide that by 2. I believe you get 247.5 degrees. Find the exact value of the sixth trig function. So I want sine, I want cosine, and tangent. And I want the reciprocal of those. So cosecant, secant, and cotangent. Okay, so here's my triangle. Always draw it back to the x-axis. So we have a -1, a -4. My hypotenuse, using the Pythagorean theorem, I have -1 squared, and -4 squared is equal to my radius squared, or the hypotenuse. Let's call that h. Okay, so then this is 1 plus 16, which is 17, and we take the square root of 17 to get h, and we have positive and negative, but we always make the hypotenuse positive. So there's my hypotenuse, rad 17. So here we go. Sine is the opposite over the hypotenuse. And that's the square root of 17. So I'm going to move it up to the top and take the square root away. Cosine, same thing. -1 over radical 17. Take the radical away, move it up to the top. And tangent is opposite over adjacent, which makes it +4. Okay, now doing the reciprocal of these, I get 1 over 4, and this is hypotenuse over adjacent, and this is hypotenuse over opposite. All right, next. All right, given tangent is 6 over 5, find the other 5 trig functions, and they tell you that we're in quadrant 1. That's what this symbol means here, right? From 0 to pi over 2. So we're in quadrant 1. Here's tangent of that angle. And tangent is opposite over adjacent, which means that the hypotenuse is going to be 36 plus 25. I believe that's going to be 61. So radical 61 is my hypotenuse. So the other 5 trig functions, they gave you tangent already, so we need sine, cosine, and then the reciprocal of those, secant and cosecant. And we already know that tangent is 6 over 5, so this has to be 5 over 6. Now, sine will be 6 over rad 61. Take the rad away and put it on top. Cosine is adjacent over rad 61. Secant, cosecant is hypotenuse over opposite. This is hypotenuse over adjacent. We're done. Find the coordinates of the point of intersection of -60 degrees and the unit circle. So we were trying to find -60 degrees on my unit circle. Here's my unit circle. -60. So this will be 45, -45, -30, -60 right here. So that's a reflection of this, right? That's a reflection of this point. And I'm using my fingers here. This is my index finger. It's kind of creepy. Okay. Alright, so this one I'm going to fold down. So that'll give me 0, 30, 45, 60, and 90. Folding this finger down, that means that cosine is 1/2 and sine is rad 3/2. I have 3 fingers on this side and only 1 on this side. And so that means my ordered pair up here is positive 1/2 comma rad 3/2. Moving that down here, that means that the x coordinate is still positive, but the y coordinate has to be negative. Okay. Use your calculator to evaluate. So I'm going to grab my calculator here, and that's in degrees. So I'm going to turn on my calculator. I'm going to check the mode, make sure that I'm in degrees. Let's see, we're in radians, so I'm going to change that to degrees. And then let's quit this and go, I want the sine of 25.1 degrees. So that will be 0.4 24 rounded 4 approximately. Okay. If possible, find the supplement of. So supplement means that it has to add up to 1 pi or 180, right? 1 pi. Well, this is going to be 1/3 pi, 2/3 pi, 3/3 pi. Oops, 3/3 pi. 4/3 pi is too big. 4/3 pi is way over here. So there's no way that you can get a supplement. Remember, supplements adds up to 1 pi, and complements add up to pi/2. So there's no supplement because it's already bigger than half a circle. All right, number 11. Use your calculator to evaluate. Okay, now I'm going to grab my calculator again. Now I just did these in degrees, so I have to go and change my mode to radians now because there's no degree sign on here. Don't forget to do that, otherwise it will not work. Tangent of 2.4. Now these are the easy problems. I don't want you to miss it because you didn't, you didn't do this correctly. Now the answer is negative 0.9160. Since that's negative, I want that to be positive, so I'm going to add 2 pi to this. Okay, I'm going to add 2 pi. So I don't remember where the pi is on my calculator. Oh, that's fine. I'm going to go 2 times 3.1415. Okay, so what I really want is 5.3670. Okay, or negative. So I want negative 0.9160, or the positive one is a better answer, 5.3670. Okay. Use your calculator to evaluate the cotangent. Now, the cotangent is the tangent except it's a reciprocal. So we want to take the tangent of 7.1, but I want to take the reciprocal of that. So I'm going to go tangent of 7.1. Remember that we were already in radians, always double check. And once we take the tangent, I want to take the reciprocal. And the reciprocal is, where is this? Ah, there's the pi button over here. There it is, reciprocal. All right, so that's going to be 0.9391. Use the picture below to find the ratio that defines the sine of b. Sine of b is up here, so sine is opposite over hypotenuse. Nice easy one. Okay. Number 14. Find the exact value of sine and cosine for the function. So sine, I want sine of A. I want the cosine of A. Well, I know that the sine of A is opposite over hypotenuse, which I don't have, but I can do the cosine. That'll be 12 over 20. Always reduce. That reduces by 4, so that's 3 over 5. Sine, you would take these and use the Pythagorean theorem. Well, if I know that this is really 3 and 5, and since we're doing trig, that means we just care about ratio. This is the 3, 4, 5 triangle. Or you can use the Pythagorean theorem with the 12 and the 20, which is kind of a lot of work, but if you know these little tricks here. So now this is 4/5. Okay. Use the fundamental trigonometry identities to determine the simplified version of this expression. So I know that tangent is sine of beta over cosine of beta. Beta is just a variable like x or theta or whatever. Secant is 1 over the cosine of beta. Well, that means the sine of beta over the cosine of beta is divided by 1 over cosine of beta, which is equal to sine of beta over the cosine of beta times the reciprocal cosine of beta over 1. These cancel, and I just get sine of beta. Here's another trick, right? Since denominators can be canceled, and this is the sine beta over 1. Number 16. Okay, for 16 and 17, let theta be an acute angle. Use the given function value and the trig identities to find the indicated trigonometric functions. So we want to find secant of theta. Well, we know secant of theta is the reciprocal cosine of theta, which will be 5 over 3. If the secant of theta is equal to rad 17, find the tangent. Well, this one's a little bit more complicated. We're going to have to draw this one. They told us it's an acute angle, so we know it's in quadrant 1. And we can draw a triangle always back to the x-axis. And if we have secant, that is adjacent over hypotenuse. So if I make that fraction, so adjacent, or hypotenuse over adjacent. So I know that. Okay. And then I want tangent, but I need this side here. If I don't have that side, I can use the Pythagorean theorem. I have a squared plus b squared is equal to rad 17 squared. Well, this is 1, and this is 17. Subtract 1 from both sides. I get b squared is equal to 16, so b has to equal 4. Okay, so that means the tangent is 4 over 1, opposite over adjacent. Find the quadrant in which theta lies. Secant is just cosine, reciprocal of cosine. So I know that all students take calculus. So if it's less than So cosine is going to be positive, cosine is going to be positive, and cosine is going to be negative, and cosine is going to be negative. Tangent's positive. I know that everything's positive here, so tangent's positive. Tangent is negative. Tangent is positive, right? All students take calculus. So tangent is negative. So where it's negative and positive would be right here in quadrant 3. Given that tangent is 7 pi over 10 and cosine is negative, find the sine. So doing the same thing, I want where tangent is positive and cosine is negative, so we're still in quadrant 3, right? So now I know that tangent is opposite over adjacent, and this will give me square root of 149, Pythagorean theorem. And cosine is negative, so we're done with that. Now we'll find sine. So sine of theta is equal to opposite over the square root of 149. Move that up to the top. Okay. All right, moving right along here. Number 20. Find the reference angle of angle that's -1 radians. All right, let's look at our unit circle again, or my quadrants. I know this is pi, or since I don't have pi's on this, I'm going to put 3.14 here. This is half a pi, which is 1.57, and this would be, let's see, -1.57, right? I'm using negative because I have a negative here. So -1.57 would be right about there. Okay, so this will be -1. This will be -1 in here. The reference angle then, since it's this way, then it's going to be just the positive one. The reference angle is always positive. You notice that these two would be the same, right? This angle here and this angle will be the same. So it'll just be whatever this looks like in quadrant 1. Okay, number 21, find the reference angle for 255 degrees. 255, this is 270, this is 180. 255 would be in here somewhere. So reference angle would be going back up to the x-axis. So that means I want to subtract 180. So 255 minus 180 is equal to 75 degrees. All right. The rules for this, well, you should remember that if it's in quadrant 3, is your angle minus 180 to get your reference angle. In quadrant 2, the reference angle is equal to 180 minus your angle. In quadrant 1, the reference angle is that angle. That's what we did for number 20. And then in quadrant 4, it's the reference angle is equal to 360 minus your angle. Now, if you just do this in radians, just change the 180 to pi. Right? If you're doing this in radians, change this to pi, and this to 2 pi. Okay, use your calculator to approximate two values. Okay, this one's kind of tricky. All right. Okay, so I'm going to use my calculator. Now, I know that cosecant of theta is equal to 1.030, and I know that cosecant is 1 over sine of theta. That means I'm going to have 1 over 1.032. Okay? So then I can flip both of these. Oh, sorry. Let me redo that. Okay, that means that 1 over sine is equal to 1.032. I can flip this around to get sine because that's the only way my calculator knows how to do this. So I'm going to have to put it in like this. Alright, then I'm going to take the arc sine of both sides to cancel out the sine. Arc sine and the arc sine. So I really have this going on. I have theta is equal to the arc sine of 1 over 1.030. In doing that on my calculator, I get a reference angle of about 1.3289. Okay, we know that arc sine is only good in quadrants 1 and 4. So the first one is going to be 1.3289. That means there's another one in quadrant 4, which is just a negative version of that. Okay, so the negative version of that would be negative 1.3289. But if you want to write this as a positive number, right, that's a reference angle. So what do we do up here? We subtract it from 360, or 2 pi. So we're going to take 2 pi minus 1.3289, which will give me approximate it to 4.9543. Okay. So there are the two angles that are that give you that. Find two exact values. Okay, now we're doing the same thing, except we're going to use our unit circle because this is something we know. Okay, if I want to go negative, all students take calculus, so it's going to be either in quadrant 2 or 2 or 3. But I know that when I use arc cosine, I have to stay within these two. So then it has to be this one because everything's positive over here. And I know that if I use my hand, this is going to be 1, 2, 3, 4. So 1, 2. So that's going to be a 30 degrees right here. I'm going to put this finger down. Okay, I put that finger down. And that means that this is going to be, yeah, this is going to be my 3 fingers over here, and that's going to give me 30 degrees. And since I'm in the negative quadrant, so that will give me my reference angle is 30 degrees over here, so this is really 150. So 150 is the first one. Okay, where else is cosine going to be negative? It's going to be over here. So that was my 30, that's my reference angle. So now I have this 30, so this will be 180 plus 30, so this will be 210. So my two angles are 150 and 210. All right, last two. Find the exact value for sine and cosecant. So we know our unit circle, 270 is down here, 180. So that means that this is going to be 210, 225, and 245. So 245 is here. For my unit circle, I can come up here. You'll be from here to here. So this is my index finger, right? My index finger. So if I put that one down, and I want sine. Sine is on this side. So this will be rad 3 over 2. And since I know that sine is negative in quadrant 3, so that has to be negative. 210, we're here, right? And we want, let's see, there's a reflection here, reflected here, so that would be my ring finger. So sine is 1/2. So this would be the reciprocal of sine, so that'll be 2. But I know that sine is negative in that quadrant, so it'll be negative 2. All right. Hope that wasn't too long.